Okay, so we're here to talk about Metal.js. So first, quick show of hands. How many of you are Flash developers? Oh, tricked you? You too? Oh, more than I expected. Okay, for those of you that are still shy, don't worry, we have time. So you'll feel more comfortable with it as the event goes on. So now, for real, who actually knows what Metal.js is? Hopefully, many of you. How many of you have played with it, have made some projects on your own time? So, how many of you have real projects, production? Pierre, what can I say? Okay, so this session aims to answer some of the questions regarding not just where we are with Metal.js right now or where we are going, but also try to uncover some of the events that unfolded and brought us where we are right now. So, if you've been in DEVCON long, for some time, you probably remember some of those sessions. So 2015, we were starting to talk about this embracement philosophy we had. We wanted to provide all the tools that you needed and to make Liferay a safe place and a modern place for web developers. And in that same event that I was saying about how we could embrace modern workflows, modern frontends, modern frameworks, Mayra also presented Metal.js. Never mind Crystal components, not happening. But Metal.js is, and that's what we're here to talk about. So this is 2015, right? And today, 2017, what's happened in between? And that's one of the most asked questions in our forums, at least the ones I'm keeping track of. It goes from how to use Metal.js, how to integrate Metal.js. What's the current state of Metal.js? Is Metal.js even a thing? Should I pick Metal.js? Should I pick something else? Right? So there are a lot of questions around Metal.js that need answers. And we've acknowledged that. But before trying to answer those, I wanted to give you some context to try to understand why we actually went ahead and built yet another JavaScript framework. So where did this all start? You saw Brian Chan's keynote before, right? So you know where did it all start. And we're not going to go that far in time. And we're going to focus on where Metal.js actually started. And we've said this before, so maybe you already know. This all started with Yahoo deprecating YUI. So if you've been using Liferay for a while, you know that for many versions, we based all of our development, or for all of our front-end code in YUI, Yahoo's library. So August 29th, 2014, Yahoo Engineering posts this seemingly innocent blog post, important announcement regarding YUI. When you read this, okay, cool, then maybe more developers are going to be there. There's a new push for this framework. Actually, hidden in there was just the mention or the announcement that Yahoo was no longer supporting YUI. Based on how fast the front-end ecosystem was moving and how they had to put all of their developers to other projects and to other matters, then they felt that YUI library was lagging behind. It didn't have the proper maintainers. It was solely moving forward based on open source contributions, and no one had the knowledge anymore to keep that project healthy. So they just decided to get rid of it. And at that moment, we were faced with a tough decision, what to do. And we were faced with this decision because we had a lot invested in it. And just to give you some numbers. So don't take this as a really deep analysis because it just took me 2 minutes, but just to give you a rough idea. At the time of this talk, YUI, which we still use, has over 1,500 JavaScript files. That includes tests, other stuff, but it's a huge number. And it gives us over almost 400 modules and around 200,000 lines of JavaScript code. That's a huge library that we had as a foundation. And on top of YUI, we decided to build Allo UI, which gave us all this set of nice reusable components. And if you look at the numbers, we have over 400 files for almost 100 YUI components that Allo UI was bringing to the table. That's roughly 70,000 lines of JavaScript code. Then we move on to Liferay Portal, which again had huge code base based on this, almost 140 modules for 50,000 rough lines of code. So imagine this huge code base based on something that's already been deprecated. So it's not an easy task. It was not an easy decision that we were facing. So what to do with this? And this is just Liferay internally. So this is what we had. But what about your own developments? What about every customer out there, every application that was actually leveraging all those modules and all that code base? So what to do with that? So we got to think about it. And knowing about it a little bit in advance, actually, we had been thinking about it for quite some time. This was back then when all this JavaScript debate, innovation, how every day there's a new framework was starting to unfold, right? And so we got the option we could bet on a winning horse maybe. But is it going to be React? Is it going to be Polymer? Maybe Angular, right? So why not pick one that's already there and let's hope it stays forever, right? So that was one of the options, but also seeing how fast everything was changing, it was a risk. So we just made a list, and we were trying to look for which things we actually needed. And the first one was that we wanted to solve common problems that every front-end developer that we have and our community was having. We needed something that provided a set of unified patterns and common utilities that everyone is using. Oops. So we wanted something that was a solid foundation for all our front-end development, something we could trust, and that was stable across ecosystem changes. So we saw that this fast evolution was actually a risk in how fast we could adapt, and we could force our customers and our community to adapt. And that's something that we need to be very careful about, because it's not so easy to just change frameworks from one day to the other, right? So we needed something that was stable. And finally, we needed something that actually appealed to our own needs. React appeals to some needs for some projects, same as Angular does. But what about Liferay? Should we change our philosophy? Should we change our stack just to be able to use one of those? Or maybe, on the other hand, can we build something that actually leverages the knowledge and the tools and the stack that we have? So with those things in mind, we did the only thing actually that we know how to do. We put our best developers to work. We flew Maira and Eduardo to Spain with Ilian. And sure enough, in no time, they had some commits in, and Metal.js was born. So Metal.js is a JS framework. No surprise there, nothing new. It's meant to build UI components in a flexible, solid way with performance in mind. And it's hard to explain what Metal.js is, so sometimes it's easier to explain what it isn't. And what Metal.js isn't is a library of components. It's not a UI library. It's not something that addresses the need of providing a whole set of components that you can just pick and use to build every application out there. So it's not trying to cover that space. It's trying to cover the developer space where you have a solid foundation and a good framework to build whatever components you need. It's also not a full-fledged framework. It's not something that can route your views and match your controllers and then do a lot of crazy stuff so you don't have to think about how you are putting those pieces together. So Metal.js is just a foundation. It's not the holy grail of whatever you need to do in your application. So knowing that, where are we now? We've talked about Metal.js in several events, several years in a row. And sometimes get the feeling that it's not clear. So that's what we're here for today. And while I was researching for this talk, I actually came up with this blog post we made in 2016, almost a year ago. And I remember drafting this post with Nate, with Eduardo, with some other people in Liferay, and how long the discussion was about what was the right messaging we wanted to do. And he actually was using the same words, where we are, right? So that's the biggest question. That's what we've always tried to address, and sometimes maybe we haven't been able to do so properly. So where are we now with Metal.js? There are 3 key points or 3 key ideas that I'd like you to take home after the talk. Metal.js is becoming the Liferay standard. Liferay standard internally. That doesn't mean it needs to be the standard for everyone, but it is indeed the standard inside Liferay. I'll explain later what it means. So Metal.js is a very stable framework. It's very stable, and it's been thoroughly tested across many different scenarios. And finally, Metal.js is becoming the foundation we set it out to be. And it's been proven to be the right foundation for the right scenarios, of course. So what I mean by standard? By standard, I mean that library, Metal.js has a library and common set of utilities. Can you hear me? Okay, so Metal.js is the library and common set of utilities and patterns within Liferay. And what that means is that Metal.js is already being used in several internal projects we have. Won't go into details about those. Oops. And some that you even know, like WeDeploy. WeDeploy is 100% backed by Metal.js. It's fully built with Metal.js. And other than those internal projects, we've open sourced some that already start leveraging Metal.js. So everything new that we're writing, it's using Metal.js. That bolting light here, that's Electric.js, which is maybe some of you have heard about it. It's a static site generator that we built and open source some months ago to help you build documentation. Actually, we built it to help us ship documentation, which is something we're somehow lacking sometimes. The other one is Clay. Clay is the web implementation of Lexicon. You might start hearing that word around. And the thing is, everything we're building for the new Lexicon implementation is based on Metal.js as well. So all the new components, all the new tools you're going to get are based on Metal already. And then the question remains for, what about existing projects? So Senna.js was already refactored to just leverage everything we have inside Metal.js. So all the core functionality of Senna is based on Metal.js. And of course, Liferay Portal. What to say about Liferay Portal? You've seen those numbers, so you can imagine that's not an easy task. Before we even wrote that blog post I showed you before, we already set a policy inside Liferay that no new development should happen using Alloy UI. So we already started way back to write our code using Metal.js. It's going to take a long time because existing places where YUI and Alloy UI are leveraged are harder to change, but we are working on that. So at least the good news is that no new code is being added in Alloy UI or YUI. No new code is being written that is not Metal.js based. And all the old code is going to be slowly being updated to leverage this framework. So we are working from within the infrastructure team and coordinating with the product teams to make sure that change happens as fast and smooth as possible. So Metal.js is stable, it's battle tested, and proof is that WeDeploy, it's based on that. It's built on Metal.js, and we feel confident enough that it can provide a very good and solid foundation. So we have the site, you can check, there's some documentation in there, and then the news about this is that even their original developers had to ship and had to move to something else, so they are all in different projects now. Different set of maintainers came in, so it's not like the project is somewhere wandering around. So some others like Bruno, Rob, and myself are now taking over. Both the bug fixing stuff plus the new features that we are developing. And if you see at the numbers, since the creation, and that doesn't include some big repository changes we did, there's over almost 2,000 commits, almost 100 releases, and 20 different contributors. So it's not like a project that's just sitting around. When you take a look at the numbers and the timelines, it might feel like, okay, this project has no activity, right? Because you know the measure of a healthy project is that it gets commits every day. It turns out, and we realize, this is not exactly the case for Metal.js. Metal.js is stable, and it doesn't really need a lot of changes. And that's why sometimes there's no activity. And there's nothing wrong with it. It's not like we've forgotten about it. It's not like that we are not using it. It's just that it doesn't need improvements, or it doesn't need changes. So bug fixes are to the minimum, and those spikes are usually when we try to introduce some extra feature. But overall, API hasn't changed drastically in over 2 years. We've kept using it without major API breaking changes for a while. So it's a pretty stable framework. And the good news is it's becoming the foundation of a lot of other tools around it. So if you check, Metal.js is actually hosted in a special Metal organization, which actually hosts over 77 different repositories. That goes or spans components. So we have a set of Metal components just built on Metal that can help and can speed up your development. We have tooling around Metal. We have a set of integration points for common workflows like Webpack, Rollup, and so on. So there's a lot of ecosystem growing around it. And I mentioned Electric before. And Electric is just a tool to build documentation sites. That's what we aim to do. And it's 100% written with Metal and backed with Metal.js. It also has around 9 repositories with different tooling, different components that can help you build nice documentation sites. This one, it's a site for this Clay library that we're building, which is built in Electric again. And all those components that we are building allow you to create these nice navigation and nice documentation features. So now we know, at least I hope you get the idea that Metal.js is well and alive within Liferay. So what are the plans we have for it? As I said, it's very stable. So we don't have crazy plans or crazy refactors in mind, crazy changes upcoming. But we do have some things in mind, some ideas. And part of this embracing modern workflows, embracing the community out there and the ecosystem, as part of that, we want to include support for web components. And we also want to recognize the importance of Node.js in the front-end world. So we are pretty much a Java stack-based company, right? So that was one of the main reasons why we picked closure templates as one of our building blocks for components. But we have to recognize that Node.js is out there. A lot of people are feeling more and more inclined to work with it and to actually ship production environments in Node.js. So being able to render Metal.js in a Node environment is actually critical to be able to deliver nice experiences there. We want to work on stabilization. I said it's stable, so this might seem a bit redundant, but we still need to we want to make it even better, even more stable. Of course, we know we have gaps in documentation. We are keeping an eye on performance, and we want to work and improve developer experience. So I'll go into detail in what those means. So web components means that, well, probably you all know what web components are, right? So do you? Yeah, okay. So web components is just this set of new specs for the web that allow you to build and ship reusable components. Who didn't try that before, right? Hopefully, so this is becoming a standard, that's the difference, and it's being adopted. And there are already several frameworks out there that can help building web components. And that's something that Metal.js wants to address as well. So a couple of months ago, or a month ago, Rob Dodson from Google released this Custom Elements Everywhere project, where it tries to test how ready today frameworks are to use custom elements. So, because we're selling this idea that you can get a custom element or a web component and then just use it as if it were any other HTML tag. So how true is that? And so he's just running a battery of tests against every known framework or every framework that actually wants to accept this challenge. And we did. And we proved, or we checked that both for JSX and Soy, which are the two template languages that Metal supports, we are 100% compatible with custom elements, as written in this spec. Okay, so maybe there may be pitfalls somewhere around waiting for us to find, but so far, Metal.js is 100% compatible with the upcoming standards. And what's more, we want to make it super easy and very easy for you to build components and leverage these new standards. So what this means is that we're working in a tool or a helper. You can see that define web component there, that you can just pass your component in, specify a tag name, and then just with that, you can use it in your HTML as if it were any HTML tag that you have around. So it's not like we're the first ones doing this, but we think it's going to be a really huge help in improving and pushing forward adoption for both Metal and web components. So what about server-side rendering? Node.js is a really key actor right now in the front-end world. Just yesterday, I think, in the Node Interactive Conference, Google engineer announced that no new commits are going into V8 development if they break Node. So it's not something that people are taking lightly, right? Even Google is understanding the importance of Node in the community. And we do so as well. So we created, a long time ago, we started discussing this, and we wanted to support out-of-the-box rendering. And truth is, it's already possible. So from Node, you can just get whatever component you created, and we have this specific render-to-string method that can give you the markup generated from JavaScript, both using JSX and Soy again. So you can just build your components, and then no matter what stack are you using, you're going to be able to render it on the server. We think it's going to help a lot in adopting different server strategies for your products and ours. So what about stabilization? Stabilization sometimes just feels like it's bug-free projects or something like that. We are looking somewhat farther than that. And one thing is we want to be able to, or we want our users to navigate the differences between other frameworks. Sometimes it's so hard to jump from one to the other because, well, you have a React developer that has some knowledge, and that's not transferable to Metal.js, right? So we want to make an extra effort into matching those expectations, making sure that everything that you can do in other frameworks is properly mapped in Metal.js. And we're going to be working hard on making sure that this is properly addressed and documented. Another part, of course, of stabilization is making sure no code is committed that breaks things and no code is shipped that breaks stuff. So we are working really hard in testing every project of those 77 repositories through putting it through a CI, proper CI, working in different browsers, different environments, testing not only functionality, but also different linting, formatting, a lot of different tests to ensure that quality, that the framework that we ship has enough quality. And we've set a policy to make sure that no new code is set or is introduced without new tests. And one thing that sometimes doesn't seem so important, but we think it is stable releases or trustable releases. So we want to set or put some guidelines in motion so that we can tell you when the next release of Metal.js is coming, what's it going to include, when are the new features going to be shipped, and have a flow in place to announce them on the site. So this is something we are discussing right now, what's the best way to do it, because, again, Metal.js was born with the idea that it should help our needs. It should address our developers' concerns. And sometimes that means that someone from support somewhere else comes with a bug that we need fixed right away. So ship and release, right? So that's something that doesn't really play well along with a common open source release lifecycle. So we're going to try to see how we can make that happen, but we want to make sure that releases happen not just on a whim and not just because someone asked to, and then features were shipped without documentation just because someone else somewhere other needed to. So I've been mentioning documentation a lot. Again, Electric.js, check it out if you want. It's been proven a really good tool for us to help with the documentation improvements. This is actually the Metal.js site, rewritten in Electric.js. It's really easy to build documentation, and that's what we have discovered that it was missing. It was so hard for us to update the sites, to write the new pages, to write the new docs. Now, with Electric.js, we can just write a Markdown file. It gets there in the navigation. You have all these components, that, like the reading progress, code, snippets, and so on. So it's really helping us write both documentation for Metal and for many other projects. So we expect to see a lot of new guides and updated tutorials coming to the Metal.js side. Other things we're working on is performance. This was a performance test that we had way back when we created Metal.js. And of course, the world has changed a lot. React has actually evolved. React 16 comes with a huge performance boost. So don't trust those numbers. Those are just vanity numbers at this time. But we haven't stopped looking at performance. And we are going to make an extra effort to make sure that performance is not something that will make you discard Metal.js. And we have something on our side that's incremental DOM, which is already a very well tested and performant foundation for all those DOM changes that we need to do. So we're pretty confident in that area. And we're also addressing code footprint, so we want to make sure that we're not just dropping a lot of code onto your project just so you know you want to use Metal.js. So we'll be working on that as well. And to finish, we want to make a special effort in developer experience. So we've been building a lot of tools based on our own experience and our own usage of Metal.js. For instance, we built this soy critic. It's like a linter, but for soy. So if you're familiar with Clojure templates, there are a different template language that you can use to render on Java and JavaScript at the same time. So we just coded some of our own guidelines and recommendations. You can run them. Here this is just like an example of the kind of warnings, errors they can throw and can give you to make sure that you write proper markup. And you can integrate this in the CI. So that's what we're doing. We've also built an accessibility checker. This is something we've had in our to-do list for a while. So it's just a wrapper around Puppeteer and a headless Chrome, fancy words. What it does is just boots up a server with a live HTML page and with your components on it. So it will warn you of whatever accessibility issues you have. So we're using this internally to make sure that all the components we're building are accessibility approved, so to say. Some other thing that we're doing is we're shifting from our custom tooling to more standard tooling. Sometimes we've lost focus of how our users were using Liferay or Metal.js or our frameworks, and that usually came with the notion that we were building our own tooling, right? So we're making a big effort in understanding how the community is moving, which tools are they using, and how to better use them in our own place. We even have a loader for Webpack. That's just another example if you need it. And this one is really cool. We built a Chrome DevTools extension that can let you explore your Metal.js components or applications. You can set the state, see how they change, see which components get re-rendered, and so on. If you're familiar with React, you probably have played with something like this before. So we think this is going to help a lot. And internally, everyone's using this, and it's helping us build better applications day in and day out. And just to finish, and to show that this is not just words in a screen, this is the next release, the 2.14 milestone that we're planning, which includes what I said before, support for both web components and isomorphic rendering. It's staged to go out. It was staged to go out today. Didn't have time, but it will be done by the week. So most of the pull requests are ready to be merged, and we'll be working on that. So what can I say? I don't know where Metal.js is going, but we know it's well and alive, and it's here to stay. So thank you.
Thank you, Chema. Can we have Chema microphone back again? Is it working? No? No. Okay, we have time for questions.
Working? Yeah, it's working.
Yeah, okay. So if anyone has questions, okay. First one.
So for the Alloy UI components, are you gonna move it to Metal.js, like it's still YUI now, or it's based on jQuery, or you guys gonna planning to move it to Metal.js? That's one question. The second one is for we deploy, what UI component are you using for that?
What?
UI components you're using for that.
Okay. Okay, so for the first question, we are not planning a one-to-one map to components, and that's part of the process we've went through when analyzing what we had in Alloy UI and YUI. One of the reasons we had so many is because, well, we built a lot of stuff that sometimes is just marginally used. So we are not going to every component and having the same component built in Metal.js. We're exploring what are the usages, how our teams are using it, how our customers are using it, and making the decision of whether it makes sense or not to rebuild it. So there's not going to be just like a one-to-one map to what you had before. But we are working on documentation to make sure that it's properly explained how to go from one to the other, what are the options, and what are we building. Before, in connection with that, just for everyone in Liferay Portal, the plan is to keep a low UI and YUI in place until whenever we release an 8th release. Okay, so for the whole 7.x life cycle of Liferay Portal, it will be around. Doesn't mean that we are going to use it, so we'll get rid of it as soon as we can, but it should be there for your components, so to give everyone time to migrate in a timely manner. Regarding WeDeploy, so WeDeploy uses standard Metal components plus some additions that they build on top that they were calling Marble, I think. I don't know about the names, but it's pretty much the standard Metal components that you saw on this repo, on the Metal organization, plus some internal ones that they just built for them. That's what shows that we didn't decide to say, WeDeploy needs this component. So let's take it to the Metal organization because this is a huge kitchen sink, and then everyone will use it from there. So we're keeping components where they make sense for us, and if WeDeploy needs a specific component, then they can build it, and they build it really fast, and then they are in charge of using and maintaining it. And that's giving us also more flexibility to adapt and to evolve the products at a different pace without burdening the infrastructure team.
Okay. Regarding the fact that Metal.js is moving into being the standard for front-end development inside the Liferay portal, the question is, what is the relationship between SOI, Metal, and JSP? And of course, taglibs, what is the roadmap of that kind of stuff? Are we going to see JSP disappearing from the portal source code? That's the question, more or less.
So the answer is who knows? And it's up to you as well. Again, we have a lot of JSPs, a lot of code out there, so it's a huge task to embrace. So in Liferay Portal, in JSPs, what we've done is a wrapper around SOI components, Metal components using SOI, that you can render on JSP. So that's at least the way we're approaching it. It's very hard to go to a team that has a deadline and a roadmap and tell them, now rewrite your JSP because, well, we don't like JSPs. It doesn't just make sense. And it doesn't make sense to push these new components and force them to rewrite their app just because now we don't want to write these components in JSP. And so what we've done is a wrapper, like a taglib wrapper, that you can use to render SOI from a JSP. And you can use that to render whatever SOI you want. Just get the template plus the context, and it will render. And then we're also using it to actually create proper taglibs. So part of this clay effort will be to provide those wrappers. So where you use a UI icon before, you'll be able to use clay icon now. And the only difference is where the one was using JSPs before, now it's actually rendering SOI on under the hood and then hydrating the components later with Metal.js. We expect that with time, once every component that you're using in your JSP is actually a SOI component, then you can easily move to a different template. So you probably could avoid using JSPs and move to SOI once every component is in place. So that's at least our thought process. But until we get there, you'll be able to use both.
Thank you.
So is it possible to do server-side rendering in Java inside Liferay Portal?
Yes.
Okay.
That was it? Yeah. So just to expand on that maybe. So we have a template SOI, same way, it works the same way, it follows the same APIs as the free marker or the old velocity one, and then the components are automatically prepared to render on the server side. If you build a SOI portlet, it will render on the server side and then rehydrate the components. If you use this wrapper, which is SOI template renderer, or the more high-level ones, they will render on the server side in Java. That's because SOI has those both versions. We can render on Java directly. It will compile to bytecode and render on Java. And then we have the JavaScript version, which allows us to render later, re-render. Not for JSX because we don't have Node. But if you want to, we have some projects in JSX that don't use Java. You can use it after we land this.
So you said soy and then Metal.js would be the combination of Liferay. So is there any sample available? I know that there's a bread sample. So is it gonna be included in that template? And then also is it gonna be the sample will be available somewhere?
Okay, so in Liferay portal, in 7.0, we already released a soy portlet, which was the imitator. So imitator was built entirely on soy and Metal.js already. So that's the biggest example you can find out there, which is mixed with OSGI magic and so on. So it might be a bit confusing. We also keep this Hello Soy portlet in there that shows all the different ways you can navigate and render and inject variables. And furthermore, we are slowly adding new components. So if you check around the code, GitHub or your own clone, fork, whatever, you can check for soy files and JS files that use Metal, and then you'll see that they keep popping up. So we have already new components like Translation Manager and new tag libs that are actually leveraging that. So there are already examples, and we hope to see more in the upcoming months.